Hello everyone, welcome back to another Stat3D5 video. I'm gonna clear this up. Okay, so in this video we are going to discuss data wrangling, data manipulation using dplyr within the tidyverse. Okay, so and we'll do demonstrations on the flights data inside this package. So if you don't have it installed, which I don't imagine that you would, we need to install packages. This thing, oops. Okay, and then it's gonna update, loaded. Yeah, I have an error message because I already have the package actually open. Okay, so this is what you would need to do. And then you should already have the tidyverse installed if you have you should have it installed already, but if you don't, same steps. Okay, so we'll load this in with the tidyverse, and then we'll look at this data set called flights. And we can see that it has a lot of rows and 19 columns. So this data set is all flights from New York City airports and Newark. So LaGuardia, JFK, and Newark from the year 2013. So lots of flights. And we can, look at the variables themselves within this flights data set by reading the documentation. One-time data for all flights that departed NYC, in 2013. And so this is a data frame with columns. We have date of the departure, the actual departure and arrival times, and carrier, flight number, just all kinds of stuff. We could also similarly view this data set. And you can see here the variables and all of this stuff: carrier, flight number, origin, destination, all kinds of stuff. Okay, so but this data set is, as we said, over 300,000 observations. So that's just really too much to actually just read the data set and learn anything about it. And so in the last video, we did some visualization stuff using ggplot, and that can of course allow us to summarize this data visually. Now we'll work on some numeric summaries and just sort of overall manipulating this data set into something that may be interesting. Now, of course, we're not going to actually do realistic data analysis. That would be for your other stats courses to hopefully teach you that stuff. In this lecture, we'll just go through the different functions for manipulating this data set into ways that could potentially be useful or useful in some other analysis. Okay, so we have tidyverse installed, and we have in particular the dplyr package called and available to us. So these are, I guess, the main concepts that we will cover. I should just give me 1 second here. Let me go to files and go to my website. This is kind of internal stuff, but I guess you can see kind of what my websites look like. And then I'm just going to render it real quick and go to, I don't want my Slack group open. I communicate with all of my graduate students and colleagues on Slack. I imagine that some of you are familiar with it. Okay, so going to the website, there is a cheat sheet for dplyr. And so this, very similar to ggplot, indicates things that you can do with dplyr. However, whereas in ggplot, we followed that cheat sheet pretty closely and referenced it, this is, in my view, the main set of operations that we'll use. And then you can study more following that cheat sheet or someone else's vignette for a very particular type of analysis where some of those functions may be called. Okay, so filter. So what this is going to do is allow us to select or filter out certain rows that we actually want. So subset the data set. So filter data set, and then say we want all values so that the month is equal to 2. Remember, I have this month variable. It takes a while to even get to month equals 2. We can't quite see it. There's a lot of data here. This would essentially be February. Okay, so now we have, when I do this, when I display it, we have a new tibble, and you can see that there's far fewer rows. Essentially, it's about 1/12 the data set, maybe a little bit less, who knows. Okay. We can also sort of do nested filtering. So if I want all flights on, say, I believe that's Valentine's Day, we can do that. Now there's 956 rows. And we get the same thing. It's a tibble when we're done with it. So because this is a tibble object, we could also view it. Okay. So you can see this data set. And yeah, you can see day and month, those cells are essentially locked because the filtering is restricted attention to rows with those values. Alternatively, we could, if you recall, like a logical operator, we could do this as well. Okay, so the main thing, and I haven't been calling attention to it until right now, is that notice that within this filter function in dplyr, I am directly referring to a variable name. And that is one of the things that makes tidyverse in general very advantageous. We saw similar stuff with ggplot, and it's the same thing with tidyverse as well. So the variable name is internally referenced. If we were to do this in base R, something that we see before, we'd have to first call the data set, which is fine. And then if we wanted to do month equals 2 and day equals 14, this is going to complain. Because month isn't really something that exists, or isn't something that exists in the global environment. Month, especially attached to this data set, doesn't exist in the global environment. So we would have to do these $signs, and we would have to do this every single time. And then we can get it. Okay, it's the same thing. It's a tibble. We're just using the data frame, or the subsetting rules that are applicable for a data frame, because the tibble is a data frame, and that for all practical purposes, at least in this demonstration, the two could be said to be equivalent in this case. It's obviously not true. They print differently, and then there's slight other differences as well. But for the purpose of wrangling and manipulating data, I could call a tibble and a data frame the same thing, and their classes are the same. So this notation, or this syntax, is not, it's just harder to read, harder to type. This is easy. This is easy. However you want to go with commas or and statements, it's up to you. Okay. All right, so, and I can, go crazy with this if I want. I could do filter flights. Let's actually keep this around, kind of like this example, and then I could do carrier equals A. Let's see if that helps if I spell things correctly. Carrier American, and I can look at all of the flights with, say, that left early, delay 0, and origin equals LGA. Okay, so a lot of stuff that I can do. Now there's only 29 rows. I have a very specific data set that I'm looking at. Valentine's Day 2013, carrier American, origin LaGuardia, and left early. Okay, and if you want to, you could, do this. So it's all in one line, or you could hit hit enter after all of the commas if you want. Okay. So that's filtering, pretty nice. Next one we'll talk about is select. So I could, for example, select flights, and I can just, again, specify the variables that I want. Month, day. Okay, so this will get month, day information. Notice that I didn't do any filtering on the rows, so we're back to a full data set. Alternatively, I could also remove columns from the data set. Okay, so if I call flights again, we can see that these are the first three variables, year, month, day. And so this selection is the same data set with those three variables removed. They don't appear anywhere in here, but they were the first three, so they would have appeared right here. Okay, so another thing that we can do, that we can use this select function for, is to reorganize the columns. So say first I want this time hour variable, which is something, you can see it here. It's the last variable in the data set. So if I want to focus on that, I could do this, but then that only works with the time hour variable in the form of a tibble. But I may want everything else. And so instead of knowing all the variables and then putting them in the order that I want, I could just preserve the ordering minus that time hour, which I'm now going to put in the front, and just call this. And now I get in the data set, reorganize slightly. Here, I'm not going to require that you know the everything function moving forward, but it just demonstrates other functions that exist and things that you can do inside the tidyverse, which we will reference in this lecture. And yeah. Okay, so something that's very nice. So we can select columns, we can remove columns, and we can reorder the columns. Okay. So notice here that it goes year, month, day. I can also do subsetting in this way. Say I know the column names and how they appear, and I want to specify, or I want to select a bunch of columns that are between two of them. So here I have year, month, day. This will pull year, month, day. Cool. So if I know the ordering of them, so in the original data set, this is the first column and this is the third column, then I can say I want the first through third column by just doing this. Okay, cool. And then last but not least, we can also use select, to rename columns. So this would produce a tibble with just that renamed column. This will take back everything. If this was a variable that we didn't necessarily want to appear first, and it is the first variable, this year variable, there's another function that is specific to the action of renaming columns, and it's called the rename function. That's nice. And that's going to just rename it and do this everything here. Okay, so we can see now A, B, C, D, month, day. Okay. Oh, I just realized that, okay, I'm doing everything, or a lot of this with the first variable in mind. This everything is, no matter what the order of these variables that you want to select is or where they came from, this is just going to do everything that isn't a variable that came before it. So let me just demonstrate that. Say I want time, hour, and then origin to appear first, and then everything. So time, hour, origin, and I still have the same 19 columns. So I pulled out time, hour, which is last, put it first, pulled out origin, which was somewhere, and then put it second, and then everything else. Okay. Okay, cool. Arrange. Okay, so that's going to order, that's going to change the row so that they're in order according to some variable that we want. So let's say, dep delay is interesting. So here, so even in just talking about wrangling, I'm still doing this with respect to some interesting variables. Okay, so these would be, so it arranges it from smallest to largest. That's the default. So here we can see flights that like left considerably earlier than their stated time. Okay, so I could go the other way and discover those, really annoying, really delayed flights, and then that would be decreasing. Okay, so now I can see flights with extremely long delays. Another way of doing this is to just use, for numeric variables, the minus right here. So it's going to take this column and then negate it and then use the default from smallest to largest increasing. But on the negative, that's now largest to smallest, or sorry, smallest to largest increasing, and then negating it is going to do largest to smallest decreasing, of course. Okay, so it's the same thing. All right, so this is more general though, so we're going to keep that. Okay, so that's great. But you may want to do something where, okay, so this is all in minutes, and normally we would communicate this kind of our delays to another human in like hours and minutes, not just like straight minutes, like 1300 minutes, 1100 minutes. It's kind of hard to know how long this is. So this is now where we can get into creating variables from other variables that exist in the data set. So I'm going to mutate flights, get dep delay hours equals dep delay divided by 60. Okay, so that's going to convert the minutes, the delay times in minutes to hours, but it's a little bit annoying that a new mutated variable by default is right at the end. So what can we do? Well, we use the dplyr function, in this case mutate, to transform a tibble, and the output is another tibble or data frame. So now we could use this as input to another one of these action functions, these verbs: filter, select, arrange, mutate. So say I really want to look at this variable, I could put it first, right? So I could use select everything. Okay, so now, oops. Oh, I need to do, yeah. Okay, now it's first, but now it's not in order. So I want to arrange this by desc dep delay hours. Okay, great. So now it's in, remember I'm dividing by minutes directly, like by 60. So this 0.7 isn't like 70 minutes or anything like that. It's 0.7 of an hour. So about 42 minutes. There's also some rounding going on. So keep that in mind. So this is 12.7 hours. You would say 12 hours, 42 minutes if I'm doing this correctly. Okay, so great. Actually, you know what? I'm gonna take this and keep this around. Okay, so I have that. Not useful if I want to actually visualize or want to print out that variable to get a sense of what it looks like. So I have to go through this nesting. So now this is where the pipe operator comes in handy. And we discussed this very briefly in another lecture video. But here, okay, let's look at, here's the context that we discussed it in. So let's say I have this sort of function composition here. Vector of integers from 1 to 10, mean of that, log of all that. Okay, so great. So the thing runs fine, but perhaps what I would want to do, if this was a more complicated example that was, like this, that was, hard to read and hard to write, then I would do this. And then you can do Control-Shift-M to just make the pipe. Oops, I want to do mean. Okay. Oh, and it's got, okay, so now I get the same answer. In the previous video, we did this as a pipe operator in base R. This is actually very new to R. And so you could, it kind of raises a conundrum of which one to teach. This is in notation in general base R. This is in the notation of the tidyverse. This, I believe, came first and is something that is widely used and widely written and widely talked about. So we're going to use this notation. Sorry, base R. Okay, so now say I want to do, okay, so I had flights. I'm interested in departure delays, but I want to convert it to hours, have that variable appear first in the data set, and then arrange it so that the longest delays, it's an order of by longest delays to shortest. Okay, so what I can do is take my data frame, Tibble, pipe, and then I can do a mutate, and then I can do my mutation equals dep delay divided by 60. Then I can do pipe, select the variable that I just created above, everything, pipe, arrange. That's already copied. Okay, that should do the same thing. Yeah, there it is. So this is the same as this. So the piping is just easier to read and it's easier to write. And it's just much smoother. And then it has this, I don't want to say and then it has this and then type of logic to it. And is sort of like creating actual sentences in the form, of course, in the syntax of this programming language. So, but it reads like, I want to call the flights data set and then create a more useful variable and then put that variable in front, make it the first variable in the data set, and finally arrange the rows by the values of that variable from largest to smallest. So it's a sentence structure, just in syntax. I mean, this is harder to see how that actually works. Okay. And now, one of the most widely used set of operations in the tidyverse for data analysis, which is this group by summarize pair, definitely in conjunction with piping. Okay, so first, let's just introduce, actually, let's do group by. So by itself, group by is not going to be that interesting. Month. Okay, so it doesn't do much. We still display a Tibble Here you can see the data set. It's the same as it was, but it does change it slightly. It changes the attributes to introduce this grouping structure, this grouping variable month, of which there are 12 distinct values or levels, if you like. Okay, so that's not that interesting. I mean, I guess you can, I don't want to do that. No, I do want to do that. You could say that now there's 365. Interesting. Okay. Okay, so, all right. So actually, and I should do the line here, but okay. So not that interesting itself. It just changes some attributes on the tibble. Okay. I get a little bit more interesting with summarize. And what summarize is going to do is it's going to collapse your data frame, all the way down to just a one row object. And it's useful when you're doing sort of like descriptive statistics is often the case that you're going to use. So let's say I do something like this. Oops. Dep delay mean equals mean dep delay. Doesn't work because there's NA values. Okay, so now we get the average delay time in the data set. And we can do more, we can add to this summary specified with columns. Okay, so actually I'm doing a few things here. Okay, so I don't need to give this a name or assign this thing a name, but if I don't, it's going to display mean dep delay in NA remove equals true as the name over here. So I'm giving it a descriptive name, which I think is fairly standard practice and very useful. Okay, so I'm going to do something similar. Take that. I'm going to take that. Okay. And then now we get a standard deviation. Cool. And there's a built-in function called n, which is just to count the operation or the number of data points. So in and of itself, this is fine. This is something that somewhat is interesting. It's providing a basic summary of the overall data set. But where these summaries get interesting is when you do them after doing a group by. So it's the chain of these two, which is really interesting. So say I want to first group by month, okay? And then take the summary that I have. Now I get summaries for each one of the months. So I can see where there are expected to be larger delays, which months have them and stuff. So, and then, we're counting the number of observations within each of the months. Okay, so that's really cool. I can also take my same thing and add another categorical variable, which is interesting, maybe carrier. And now look, I get broken down by month and carrier combination. Can I do arrange desk? I mean, I think this is the tibble outputs. I don't see why this is, yeah. Okay, cool. Okay, so some interesting things here. I don't know what airline this is, but it only had one flight. So, and it was delayed by 67 minutes. So there's no standard deviation because how do you compute a standard deviation from one observation? You can't. And here we get OO with a few more. But so they're not looking too good. I don't know too many of I don't know airlines. I really don't. So perhaps these are all standard. Okay, so cool. But I can, again, this whole thing, once the summary is called and run, this is just another tibble of which I can go back and start doing more things with it. That's what I just did there. Cool. Okay. I could do the same thing and just look at carriers directly and not be concerned with the month. Okay. And you can see here that there's 16 carriers in the data set. That's nice. Cool. And again, that same trick. Desk. Deptil, I mean. Okay, so we can see US airlines down here. That's pretty cool. It's the lowest delay on average, and has a relatively tight standard deviation. That's pretty cool. Maybe some sort of Poisson distribution with some over or under dispersion will model this well. Okay, we don't need to get into that. After converting to discrete values. Okay, cool. I can also, actually, let's go back to this one where I did month carrier. Same thing. Remember, it's going to output a tibble. And this one was long. I could view it. And you can see the whole information. And then in the viewer, you can do this stuff. You can arrange it. That's pretty cool. Okay. Don't need that. Awesome. All right, so let's see here. What else is there to do? These are the main concepts. Filtering. Select. Arranging. Creating new variables using mutate. Pipe operator. And group by summarize, often in combination with each other, mostly in combination with each other. Okay, so let's go to, just for completeness, let's go to our handy dandy cheat sheet for dplyr. And just look at something that looks, extract cases, group by, row wise. Mutate, transmute, rename. What's something that's okay? Yeah, you can see everything. It's here. Oh, this is interesting. This is good for joining things together. So this is like you can create data frame, or you can create tibble data frames by you can like merge them together, which is very nice. So like if you had let's see here, what would be a good example in this flight context? So if you had all the flights from 2013, you had all of this information, but then you had a data set that had like average cost of flight ticket or something, and now they're two separate data sets, but you want to work them together, you can join them in. And if it has the same type of identifying information on both data sets, then you can do this very easily using these joins. Okay, count, we actually did. By full join, all kinds of stuff. Wait, let's see here. Arrange. I'm looking for one in particular. Okay, yeah, it's cool. We have all the operations. Yeah, let's just do that. We saw it before. Let's do, okay, so I went to my cheat sheet, and then I saw, actually, I'm gonna do this in combination. Let's do, okay, give me 1 second. Does my cheat sheet have pull. Okay, so I have these math operations, and I want to use one of them on one of the the variable names. Okay, you know what? Okay, so I'm going to do, so here's the tibble that I have. Oh, bad. Okay. Okay, so here's the tibble that I have, and I want to select a quantitative variable. We'll say depth delay mean, and then I want to take the mean of it, I guess, or the log. So I can do, okay, let's just do the log. And there we go. Whoops. What happened? Oh, I know what happened. Filter greater than 0. Now, there we go. Okay, now I can take the log of everything. Great. Okay. All right, so yeah, pretty powerful stuff for data analysis. So in summary, again, we have a cheat sheet that you have for dplyr, and you have these main verbs for working with it: filtering, selection, arranging, mutate, group by summarize, and then chaining them together using the pipe operator. All right, so yeah, thank you for your attention, and I'm going to stop now, and I will see you next time and we'll go over lab 6. All right, bye.